All right, so we're going to go ahead and go over the notes for this and look at how we would find a specific term. And there's two main ways that you can go about doing this. One, you can do Pascal's triangle. So for Pascal's triangle, we have 1, 1, 1, 2, 1. How do we get those? You add those. Then 1, that is 3, 3, 1, 1, 4, 6, 4, 1, because those two are gives you the 6. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. And 1, 7, what is that? 21, 35, 35, 21, 7, and 1. So this is the 7th row, and I want the 4th term, so 1, 2, 3, 4. So I'm going to multiply 35 times, and I like to just put everything down below here. X, counting down, this is x to the 7th, 6th, 5th, 4th. And y is the rest of it. These two numbers, the 4 and the whatever number I'm going to get from my y, my exponent, has to combine. Let me make this a little bit bigger. Has to combine and add up to 7. So this must be my 3. Again, each of those guys always have to add up to that. So since there's no other coefficients, I just multiply all those together. Now, how else can you get 35? The other way of getting 35 is actually using a factorial. So that's not very clear. That's better. The other way of getting 35 is actually using factorials, and that is that this is the 7th row. So I would have 7 factorials, and really what we're doing here is saying this is choosing 4, like a group of 4, and you have your winners, and then you have your leftovers, or your losers would be the much stronger term for that. So if I did this 7 times 6 times 5 times 4 factorial, I stop at 4 factorial because all of those are going to go away, and then 3 times 2. 6 gets away with 6. You end up with 7 times 5, which is indeed 35. So again, the formula would be your total. Sorry about that. Let's write that again. Total exponent up on the top, x factorial, and then this is going to be your first term exponent, and then this is also your second term exponent. So in this case here, it would have been 7 factorial over 4 factorial and 3 factorial. And you do need to actually figure out the fact that this is a 4th and this is a 4th is it isn't always that way. I just want to make sure that we're clear on that, and we'll look at it here of what happens. So for this guy right here, I want my 12th term. Well, I don't want to fill out the rest of Pascal's triangle all the way to 12. So I'm going to use this little terminology here. So this is 13 factorial over, but here's the thing. My 12th term, I have to count backwards. So this will be 3x quantity 12 to begin with. Quantity 13 to begin with, and then I'm going to count down all the way down to the 12th term. So 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. All right, so this one here would actually be my x, 3x squared. So this is going to be my first term exponent, and then remember these two things always have to add up, so then this is 1 to the 11, and then my number that I'm looking for here I need to figure out here. So again, this is then 11 factorial. So do you see the 12th term? Neither one of those are 12. So again, this is just kind of a special little case of why it is that that happened. So I do end up getting, let's see, 13 times 12 times 11 factorial over 11 factorial. Those are nicely goes away, and then that's 2, which reduces to, it's really 13 times 6. So 78 is the number. So I have my coefficient, I have this guy that needs to be squared, and then this guy that needs to be to 11th power. So I have 78 times, this is really 9x squared, and then this is really just 1. So I multiply all those numbers together, which is really ultimately 78 times 9. So 702x squared is actually the term that I'm looking for.